This is the recording for the first topic, which we're talking about lines and circles. And in this topic, there's a lot of terms and definitions that we have to get used to. My suggestion is to make sure that you print off the lesson notes for this lesson so that you can follow along, and make sure that you are able to recognize the different parts that go along with what we're talking about. And our first definition is a circle, and a circle is the set of all points in a plane that are an equal distance from a given point called the circle. So there's your circle, and your center is in the middle. A radius is a line segment from the center of the circle to any point on the circle. So again, you start off with the circle, and then the radius goes from the center to any point on the circle. And again, that is what we call the radius. Next definition is for a chord. A chord is also part of a circle, so we start off with our circle. We've got the center of our circle, and a chord is a line segment that joins any 2 points on the circle. So this time it doesn't say anything about going through the center. So a chord just goes from one point to another point. Does not have to go through the center of the circle. That's a big difference between that and the radius, which does go through the center. A diameter is a chord that passes through the center. So if we start off with our circle, we identify the center of the circle. A diameter goes directly through the center. In any circle, there are numerous diameters that you could draw. If you just kind of watch, we could go from this point through the center there. You could go from this point through the center there. So there's not only one diameter that can be drawn, but just make sure that it goes through the center. And a secant is a line that passes through 2 points on a circle. So once again, you start off with your circle, identify your center, and a secant goes through 2 points of the circle. That's one, or again, does not have to go through the center. And let's move on. The circumference is the distance around a circle. So if you just look at a circle with the center, the circumference, let's say you start here, the circumference goes around the outside. Okay. When I think of circumference, I like to think of a bike tire, and it's not the entire circle shaded in. The circumference is the distance around. There are 2 different formulas that you can see right here for the circumference of a circle, and we're missing a major part here. Did not copy over, it must have been. The 2 formulas, let's not pay attention over here. 2 formulas to find the circumference. Circumference is equal to 2 times pi times the radius, or the circumference is equal to pi times the diameter. So those 2 formulas, 2 pi r or pi d. Now what the interesting analysis that you want to make here is a radius is halfway through the circle. 2 radiuses makes a diameter. So if we look here, 2r two radiuses makes a diameter. So that's how those that formula is related. Next, we have another circle, another center, and a tangent is a line that intersects the circle at only one point. So a tangent intersects the circle, once. I need to change that a little bit. Okay, there we go. At this point, it's now touching the circle only once. Only right here, one little point, does that tangent line touch the circle. Now, another interesting point on tangents that we will bring up later, if you are to draw the radius from the center of the circle to the tangent, it will intersect with that tangent in a 90-degree angle. Now the one that I just drew here freehand doesn't exactly look like it, but a tangent intersects the radius drawn from the center in perpendicular line. Now these next two, the diagrams for them are a little bit more advanced, so I'm going to have to copy it in. A common tangent that does not intersect the segment joining the centers of the circles is called a common external tangent. Okay, bear with me. Okay, this is the diagram that represents that, and let's take a minute and let's analyze what we're talking about here. First, what we've done is we have gone ahead and we have drawn a segment joining the centers of the circles. The segment joining the centers of the circles, that's this little red line that's about to be a yellow line. Okay? And now a common tangent that does not intersect those. If we look at, let me see if I can make them blue. This line here, okay, that worked. That blue line that I just drew does not intersect the yellow line. This is tangent to this circle, this is tangent to this circle, so they're each tangent, but it doesn't intersect the yellow line. You can do it again here with that tangent point and that tangent point, and again it does not intersect this yellow line, and that's called a common external tangent. Think external, outside. Whoops. And we can now compare the difference between the common internal tangent. Let's do the same thing. Doesn't intersect the segment joining the centers of the circles. The segment joining the centers of the circles is the yellow line. And then if we draw our blue lines, tangent to tangent, now this time it does intersect that yellow line. This one does intersect that yellow line, so those are called common internal tangents. External does not intersect, internal does intersect. Okay, so time for some examples and to do some problems. Find the diameter of a circle with radius 6 inches. Find the diameter, okay. There are two formulas for circumference. Circumference is equal to 2 pi r. Circumference is equal to pi times the diameter. Okay, but since neither of these examples are asking us about circumference, we'll just table that for later discussion. I think I just put those circumference formulas in there for reference in case you do need them. But what we're looking for is we want the relationship between the diameter and the radius. And if we think back to what we just talked about, given a circle, radius, diameter, the difference between the radius and the diameter. The radius is twice as, or the diameter is twice as long as the radius. 2 times the radius is equal to the diameter. You're given a 6-inch radius, so just replace the r with 6. 2 times 6 equals d. 12 equals d. So if a radius is 6 inches, then the diameter, you're going to have another 6-inch radius over here. The whole thing will be 12. Other way around, find the radius of a circle with a 15-inch diameter. Same formula. 2r equals d. The diameter is twice as long as a radius. This time we know we have a 15-inch diameter, so replace the d with a 15. 2r equals 15. Divide both sides by 2. Okay. 15 divided by 2, 7.5. R equals 7.5. Alright, last one is to take a diagram and analyze and identify all of the different parts and definitions that we talked about on those first couple pages. There may be more than one answer, so make sure you are as specific as possible. Radius. Radius goes from the center to an outside point. The first one that I see is this segment right here. So CD is a diameter. DE is also, DE is also a radius. And we have one more going right here, DF. Okay, those are our 3 radiuses, radii. RADII is the plural form of radius. Okay, diameter is a chord of the circle that goes through the center. The chord of the circle that goes through the center. Right here. So our radius, or our diameter, is CE. Chords. Now a chord is more general. The diameter is the name of a specific chord, so we can write CE down here again, because definition of chord just means that it connects a segment connecting 2 points of a circle. CE definitely does that. AB also does that. From A to B, just goes from one point to another point. A chord general does not have to go through the center. Secant, definition of a secant is that it goes through 2 points of a circle and then goes out to the exterior, and we do not see any secants here. If I draw one in so you can see what it looks like, a secant goes through 2 points and then continues on. So we don't have any secants. And a tangent, the definition of a tangent is that it intersects only once. We do have one of those right here. and it doesn't give us 2 points to name that line, so we are just going to have to identify that as line G. And in math, a common way of identifying lines is with a cursive L. I know you don't see cursive too much anymore, at least I don't, but if you see a cursive L, that signifies line G. Alright, one little problem to solve. If DC is 4, find CE. DC is 4. We want to find CE. DC is a radius. We want the diameter. So again, go back to our other formula. 2 times a radius is equal to a diameter. 2 times 4 is equal to our diameter. 8 should be our diameter. Oops, 8 will be our diameter. If CD is 4, that means all the radii will be 4. And then you can just think 4 plus 4 makes 8. Okay, let's move on. Oh, alright, that's it for topic 1. It's just looking at all the different terminology of a circle and then identifying it on different graphs. If you have any questions, please give me a call or send me an email. Thanks so much.